By the end of this video, you will be able to find sector area both in radians and in degrees, segment area both in radians and in degrees, and arc length on a circumference. Let's find the area of the sector. The sector is the shaded area. Before we solve this problem, consider watching the following videos, especially on how to find the area of a triangle with a given angle. A sector is like a circle pizza shape. Apart from a slice of pizza, these are other real-life examples. A segment, rather, splits a circle horizontally like a window blind, except for the diameter. But every other line here is known as a chord. A shaded area within the chord is known as a segment. We have the major sector and the minor sector. Likewise, we have the major segment and the minor segment. Consider a sector. If the angle at the center is in degrees, then the area of the sector will be the area of the circle multiplied by the ratio of the angle to 360. However, if the angle at the center is in radians, then we're going to multiply the given radian by 1/2 multiplied by r squared. The central angle will determine which of the formulas to use, unless otherwise stated. Step number 1. Consider the angle at the center. The given angle is in degrees. Next, step number 2. Choose the right formula for degrees, which is this. Step number 3. The area of a sector is the area of a circle multiplied by the given angle divided by 360. Next, we're going to substitute for the radius, which is 8. Substituting and solving carefully, our answer is 32/3 pi. And here we have left our answer in terms of pi. If we take pi to be 3.142, which is a constant, then our real value is 33.51. The next step is to consider the units. Area is usually in centimeters squared, meters squared, inch squared, but here 8 has no unit, which is the radius. Hence, our area has no unit as well. Next, find the area of the given sector. Step number 1. Consider the angle at the center. Here, the angle is given in radians. Step number 2. Choose the right formula for a given angle in radians, which is 1/2 multiplied by r squared multiplied by the angle, which must be in radian. Next, we're going to write out the formula. And in the next step, we're going to substitute for the radius, which is 6 meters, and also for the angle, which is in radian, 2 pi divided by 3. Next, we're going to simplify our result. These two we take a radius to, and our answer is 12 pi, which has been left in terms of pi. Next, consider the unit. The radius is in meters. hence the unit is meter squared. But pi is 3.142, hence the real value of the area is 37.70 meter squared to 2 decimal places. Next, let's find the area of the sector. I'm going to solve this problem using degrees formula and radians formula. That is, using both formulas. And let us see if we can get the same answer. Let's start with the degrees. Considering the angle in degrees, the area of the sector will be area of the circle multiply by the given angle, then divide by 360. Next, we're going to substitute for the radius. Next, we simplify. This 5 will take away 5, and we are left with 5 pi. Next, we consider the unit, which is in centimeters. Hence, we're going to have centimeters squared. Here, we have left our answer in terms of pi. But if you substitute the value of pi, you can get the real value of the area. Next, let's use the formula for the radians to see if we can get the same answer. The first step is to write out the area in radians. First step is to substitute. But here we have a problem. This angle is in radians, not in degrees. But 72 is in degrees. To convert the degrees to radians, we need to multiply the degrees by pi over 180. By this conversion, we can go ahead to simplify. Next, these 2 will take away these 2, and 5 here is 1, while 5 here is 5, and our answer is 5 pi. Next, we consider the unit, which is in centimeters, and the unit is centimeters squared. You can see that using any of the formulas will give you the same answer, as long as you know how to convert from degrees to radians or from radians to degrees. Next, we had solved this problem earlier using radians formula. Let's repeat the solution using the degrees formula. Using the degrees formula, we're going to have the central angle divide by 360 multiply by the area of the circle. But we have a problem here. The central angle is in radians. However, this formula is for degrees. To correct this error, we're going to multiply the given angle by 180 divide by pi. This will convert it from radians to degrees. With this conversion, we can simplify our result. Here, pi will take away pi. 3 here is 1, and 3 in 180 is 60. Simplifying further, our area is 12 pi. And since the radius is in meters, the unit will be in meters squared. You can see, using the degrees formula, we obtained the same answer that we got using the radians formula. The area of a sector is 8 pi and the radius of the circle is 12. What is the central angle? Here we have a sector, and here we are not sure if x is in radian or is in degrees. Both formulas will lead us to the answer. Let's try the degrees. The area is 8 pi, while the radius is 12. At the numerator, everything will multiply and you're going to get this. And 360 will multiply at the denominator and you're going to get this. Next, we cross multiply. 360 will move to multiply 8 pi and we're going to get this. Next, pi will take away pi. Simplifying further, the central angle is 20 degrees. Next, what is 20 degrees in radians? To convert degrees to radians, you multiply the degrees with pi divide 180. 1 over 9 pi is the same thing as 20 degrees. You see that the unit of the radius is not important. This is the degrees formula. Let's repeat this question using the radians formula. Using the radians formula, the area is 8 pi from the question and the radius is 12. Next, 2 will cross multiply to multiply 8 pi. 8 pi multiplied by 2 will give you 16 pi. However, we want to isolate s, and 144 will now move to the other side to divide, and x becomes 1 over 9 pi in radians. How do you convert radians to degrees? You simply multiply it by 180 divided by pi. Next, pi will take away this pi. 9 here is 1 and 9 in 18 is 2, and you now have 20 degrees, which we have obtained using the radians formula. However, we got the same results using the degrees formula. Let's consider how to find the area of a segment. This line is known as a chord, and the shaded portion is known as segment. Usually within a circle, a segment is inside a sector. This is a sector. Inside a sector is both a segment and a triangle. Then a segment is a sector minus the triangle, which is this portion. There are 3 ways of finding the area of a triangle. The first one is when you have the base and the height. Next is when 2 sides are given and an angle. And the next one is when you have 3 sides, no height and no angle, where S is the semi-perimeter, which is the addition of the 3 sides divided by 2. Any of these can help you to find the area of a triangle. But in this video, because of the central angle, we are going to use this formula to find the area of a segment. We are going to use this formula when the central angle is in degrees, and this formula when the central angle is in radians. Find the area of the segment with radius 24. We want to find the area of this segment, which is enclosed in a sector. Step number 1. Consider the angle at the center. The angle at the center is in degrees. Hence, we're going to use area of the sector minus area of the triangle. In step number 2, we choose the right formula. And in step number 3, we're going to write out the formula and substitute, which is the area of the sector, which is 603.264 meters squared. Next, we're going to find the area of this triangle, which is 1/2 multiplied by the two sides of the radius multiplied by the central angle. Using the area of a triangle with a given angle, our answer is 249.415 meters squared. The area of the segment is area of the sector minus area of the triangle, which is 353.85 meters squared. How do we find the area of a segment with a given angle, which is in radians? The angle is 2 pi divided by 3, which is in radians. The first step is to consider the given angle, which is in radians. Next, choose the right formula. Here, for radians, it is the area of the sector minus the area of the triangle. The angle for this formula of a triangle is usually in degrees. Hence, we're going to multiply this by 180 divided by pi. From the area of a sector with radians, when you substitute and solve carefully, you're going to get 67.0293 meters squared. Next, let's find the area of this triangle. The formula is half multiplied by the two given sides multiplied by theta. This theta for the triangle is usually in degrees. To be able to subtract from radians, we're going to multiply this by 180 divided by pi. Next, pi will take away this pi. 3 here is 1 and 3 here is 60. When you simplify further, your answer for the area of the triangle is 27.7128 meters squared. The area of the sector minus the area of the triangle is 39.32 meters squared for the area of the segment, to 2 decimal places and 4 significant figures. Alternatively, in the calculation of the area of a triangle, we can maintain the angle of the radians without conversion. However, pi inside a trigonometric function is equal to 180 and not 3.142, which is pi outside a trigonometric function. Hence, because of the presence of this trigonometric function, which is sine, pi will be 180. Our answer will still remain the same, and the segment area will still remain unchanged. Let's consider how to calculate the length of an arc. If the central angle is in degrees, then we're going to use this formula. But if the central angle is in radians, then we're going to use this formula. The circumference of a circle is the total length if we unroll it. Any length short of the circumference is known as an arc. Let's find the length of this arc. Step number 1. consider the central angle. Here, the central angle is in radians. Next, for the length of an arc in radians, we are going to choose the right formula. If you substitute carefully, the length of the arc is 12.57 meters. Remember, the radius is in meters. We can achieve the same result using the degrees formula. In the formula, this is in degrees. However, this is in radians. To convert this, we are going to multiply it by 180 over pi. Pi will cancel out this pi. 3 here is 1 and 3 here is 60. Computing carefully, we obtained the same answer. When the central angle is in radians and you have to use this formula, then you must learn how to convert. Else, you have to use this formula. Next, let's find the length of this arc. The first step is to consider the central angle, which is in degrees. Next, choose the right formula for central angles with degrees. If you substitute and solve carefully, the length of the arc is 43.99 centimeters because the radius is centimeters. Let's repeat the question using the radians formula. The radius is 8 and the angle is 315. But in this formula, this angle is in radians. However, the question is in degrees. To fix this problem, we're going to multiply the angle by pi divided by 180. If you solve carefully, you're going to obtain the same answer. If you must use the radians formula for a given degree, then you must learn how to convert. To convert degrees to radians, you're going to multiply by 180 divided by pi. Likewise, to convert from radians to degrees, you're going to multiply by pi divided by 180. Always remember this. If this video was helpful, don't forget to subscribe, like, and share. To locate and access other helpful videos, follow the link on the screen. I will see you in the next video lesson.